We could solve the previous example in LCM method. First, remove the brackets by multiplying the signs before and after the bracket. That's usual. We get negative 5 over 9 minus 4 over 3. Now let's use the LCM method. Before we get into this, let's know about LCM. Well, LCM stands for least common multiple. Firstly, what is multiple? We get a multiple of a number when we multiply it by another number, such as multiplying by 1, 2, 3, 4, etc. but not 0, just like the multiplication table. Here are some examples. The multiples of 2 are 2, 4, 6, 8, 10 and so on. The multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24 and so on. Now, what is a common multiple? Say we have listed the first few multiples of 2 and 3. The common multiples are those that are found in both lists. Notice that 6, 12 and 18 appear in both lists. So, the common multiples of 2 and 3 are 6, 12, 18 and 24, 30, etc. Now, what is the least common multiple? It is simply the smallest of the common multiples. In our previous example, the smallest of the common multiples is 6. So the least common multiple of 2 and 3 is 6. Here, in this example, there are 3 steps to follow to evaluate negative 5 over 9 minus 4 over 3 using LCM. Step 1. Find the least common multiple of the denominators, which is called the least common denominator. There is the fastest way to get the least common multiple, and the method that I love to use is called the division ladder. For that, start off by writing the denominators on one line like this. Then make an L. Here is what you are going to do. You are going to set up something that looks like an upside down division bar. And we are going to think about prime numbers, any prime numbers that can go into both 9 and 3. Prime numbers? By the way, a prime number is a number greater than 1 which is divisible by 1 and itself. For example, take 5. 5 is divisible by 1 and it is divisible by 5. There is no other number which can divide 5. Hence it's a prime number. Now let's consider 9. 9 is divisible by 1, 3 and 9. Apart from 1 and itself, it is also divisible by 3. Hence, it's not a prime number. Now back to our example. Here we are going to think about prime numbers, any prime numbers that can go into both 9 and 3. The only prime number we can divide them by 3. So we have 3 into 3 is 9 and we have 3 into 1 is 3. Right now, we have a prime number 3 and 1. As soon as you get the prime number or 1 in the division ladder, just close it. That's our endpoint. This is the process to get LCM. So that I am going to make a big L with the outside of my division ladder. And what I am going to do with all those numbers that are contained in the L, just multiply them all together. So LCM is going to be 3 times 3 times 1, which equals 9. Step 2. Change each rational number using the equivalent rational numbers to make their denominators the same as the least common multiple. In order to make the denominators the same, note, what we do to the bottom of the rational number, we must also do to the top. So let's try using it. We want both denominators to have 9. 5 over 9 already has a denominator of 9, but here the denominator is 3. So when we multiply top and bottom of 4 over 3 by 3, we get 12 over 9. Step 3. Add or subtract the rational numbers as you wish. Now we can do the subtraction by subtracting the top numbers. Put the big divide and leaves the denominator 9. Then calculate the numerators, negative 5 minus 12. We get negative 17 over 9. Is rational number already in the standard form? So this is our final answer. Now let's add these numbers in LCM method. So write the denominators 12 and 10 and make an L. Here we are going to think about prime numbers, any prime numbers that can go into 12 and 10. And for me, the only number that come into my mind is 2. So we have 2 into 6 is 12 and then 2 into 5 is 10. Now we have 5 is a prime number but 6 is not. So again I am going to make a division ladder. 6 can be divided by prime numbers 2 and 3. You can divide 6 by either of them first, any one of them is fine. Here I am going to choose 3. So we have 3 into 2 is 6. And here is the thing, 3 cannot go into 5. In this case, just copy the number 5 as such. This is the process to get LCM. Right now we have 2 and 5 which are prime numbers, right? Remember that I told, as soon as you get the prime numbers or 1 in the division ladder, just close it. That's our endpoint in our division ladder. So that I am going to make a big L with the outside of my division ladder, and what I am going to do with all those numbers that are contained in the L, just multiply them all together. So LCM is going to be 2 times 3 times 2 times 5, which equals 60. Because 2 times 3 is 6. And that 6 times 2 is 12. Then that 12 times 5 is 60. Now we found the LCM. So here, let's try to make the denominators the same. When you multiply 12 by 5, you get 60. And then when you multiply 10 by 6, you get 60. Just make sure that what we do to the bottom of the rational number, we must also do to the top. So, negative 7 divided by 12 becomes negative 35 divided by 60. And negative 3 divided by 10 becomes negative 18 divided by 60. As you can see now, we change each rational number's denominator the same as the least common multiple. So we can combine the top numbers. First put the big divide and leaves the common denominator 60. Then write the numerators, negative 35 minus 18, which equals negative 35 minus 18 is negative 53 divided by 60. This is in the standard form. In other words, we can't simplify it further. So this is our final answer. Now let's try another one in LCM method. LCM method makes our calculation easy when we are dealing with bigger numbers and more than 2 rational numbers. So first write the denominators 16, 24 and 30 and make an L. Here we are going to think about prime numbers, any prime numbers that can go into 16, 24 and 30. And for me, the only prime number that come into my mind is 2. So we have 2 into 8 is 16. Then 2 into 12 is 24. And we have 2 into 15 is 30. Right now we have 8, 12 and 15. These are all not prime numbers. So again I am going to make a division ladder and think about prime numbers, any prime numbers that can go into 8, 12 and 15. No prime number can divide all these numbers simultaneously, right? So that I am going to think about prime numbers that can go into at least 2 of them. For me, the prime numbers that come into my mind are 2 and 3. I'm gonna choose 3 here, any one of them is fine. So here we cannot divide 8 by 3, so just copy the number 8 as such. Then 3 into 4 is 12 and 3 into 5 is 15. Right now I'm gonna try to divide 8 and 4 by the prime number 2, since 8 and 4 are not prime numbers. We have to keep doing it till we get all prime numbers at the bottom of our division ladder. So 2 into 4 is 8, then 2 into 2 is 4. And 2 cannot go into 5, so just copy the 5 as such. Still, we don't make them all prime numbers. I mean, 4 is not a prime number, right? So, again I am going to make a division ladder. And think about prime numbers, any prime numbers that can go into 4. For me, the only prime number that comes into my mind is 2. So we have 2 into 2 is 4. And 2 cannot go into 5, so just copy the number 5 as such. At the moment, we have two prime numbers 2 and 5 and 1 at the bottom of our division ladder, right? Remember that I told, as soon as we get the prime numbers or 1 in the division ladder, just close it. So that I am going to make a big L with the outside of my division ladder, and what I am going to do with all those numbers that are contained in the L, just multiply them all together. So LCM is going to be 2 times 3 times 2 times 2 times 2 times 1 and times 5, which equals 240. So we found the LCM. Now let's try to make the denominators the same. When you multiply 16 by 15, you get 240. Then when you multiply 24 by 10, you get 240. And when you multiply 30 by 8, you also get 240. Just make sure that what we do to the bottom of the rational number, we must also do to the top. So 3 over 16 becomes 45 over 240 plus 7 over 24 becomes 70 over 240 and minus 11 over 30 becomes minus 88 over 240. As you can see now, we change each rational number's denominators the same as the least common multiple. Now we can combine the top numbers. First put the big divide and leaves the common denominator 240. Then write the numerators 45 plus 70 minus 88. Now calculate the first two numbers 45 plus 70, which is 115. And that 115 minus 88 equals 27. Hence, we get 27 over 240. And if we cancel the numerator 27 and the denominator 240 by the common factor 3, we get 9 over 80. This is in the standard form. In other words, we can't simplify it further. So this is our final answer. Summary. To put your new knowledge into practice, try the your turn questions below.